Hello friends, it's MoNaCo here. We're going to be doing our fourth homework notes video. We're focusing on elements versus compounds today. So of the pure substances that exist, we're going to talk about elements and compounds and how they're written in chemical notations, like so the H2O, that kind of thing, how we get there. We're going to identify different elements by type and number present in simple chemical compounds by using subscripts and that notation that many are familiar with but don't necessarily understand the details. We're going to write element symbols for the common elements using the rules for writing element symbols. You're going to understand a little bit more about why aluminum's symbol is capital A lowercase l when the name is aluminum. Or you're going to understand those rules for naming an element from its symbol and symbol from the element back and forth. Okay? So let's get our intro and our lead in here. How do we write symbols for pure substances in chemistry? If you look at this little diagram here, we see our particle models. There's only three pure substances here. D is not pure. That's actually a mixture. And in this larger picture here, you actually see both particle type models and the common notation and names for some very common chemical compounds and elements. The first row here, hydrogen, oxygen, nitrogen, and chlorine, those are all elements because it's two atoms of the same type connected together. In the second row here, we have our compounds because we have different types of elements connected together to make a compound. And as a result, we get these different types of chemical formulas. And we're going to investigate those in a little bit more depth right now. Okay. So, elements versus compounds. We're going to find and circle all the elements and underline the compounds below. Elements are symbols that are by themselves or in packages of two. O2, element. C, element. Mg, element. You might say, well, that's two letters, mister. How come that's an element? Well, the first one's a capital and the second one's a lowercase. So that's kind of going to give you a clue as to that is an element, not a compound. He, capital H, lowercase e, by itself, that's a pure element. Capital C, lowercase u, by itself, that's a pure element. Capital C, lowercase o, by itself, there's an element. Cl, but there's two of them connected, that's chlorine, there's two of those, that's an element. And I by itself, that is an element. Well, that leaves everything else to be a compound. So CO, C2H5OH, H2SO4, compound, AlCN3, H2O, Ni3, and NaCl. Those are our compounds. And our second instruction is saying on the space provided, record the number of different symbols within the species to the left. Well, here, CO, we've got 1, 2. Two capitals, so there'd be two symbols used. Here we have C, H, O, and then another H, and it does ask for different symbols. So we're going to call this a 3. 3 there. For this one, we've got H, S, and O. So there's 3 total different symbols. Now the 2 here doesn't count as a different symbols. We're talking about the letters in their symbols. So there's only one symbol in that one, one symbol there. One symbol there because, again, the little case g goes with the capital M. That makes it a pure element. For this one, we've got A, L, C, and N. So there's 3 total symbols. I think you get the idea here. You're going to count the symbols. Okay, so you can do the remainder on your own in your notes packet. The questions associated with this is, does each compound have the same number of symbols? Each compound have the same number of symbols. For example, here's a compound with 2 symbols in it. Here's a compound with 3 symbols in it. Well, automatically right there we have our answer. It's no. Okay? For each element above, how many total symbols are listed? Well, the elements, we've got 1 symbol, 1 symbol, oh, another 1 symbol, another element, 1 symbol, 1 symbol. Every single one of them has a 1 symbol. What is the minimum number of symbols that must be present in order for a species to be considered a compound? Well, compounds never have 1 symbol, it looks like. They've always got 2 or more. So the minimum number would be 2. Okay? So a little note there, elements always contain one symbol only. And a compound is a formula which contains 2 plus different symbols, or 2 or more different elements. Okay. So let's move on and actually count some atoms in formulas. Okay. Let's get our examples out here. CO2, Al, CN3, and Fe2, SO4, 3. Within a compound, you're going to see many subscripts. A subscript is a little number underneath. These subscripts tell you the number of each type of atom that is present. So in this case, the carbon atoms, there is not a number present, just like there is no number present in front of the mythical number x in algebra. We always assume that is a 1 in front there. So we assume there's a 1 in front of the x. When we do not see a number after or in the subscript for an element, we assume that there is a 1 there. Okay, so we assume that there is only one carbon atom present. And in the 2 is a dead giveaway, there are 2 oxygens present. Now in this next example, if there's a parentheses, the subscripts applies to everything within the parentheses. And one way to think about this is to do the distributive property. You're going to distribute the 3 into whatever's on the inside. The aluminum has no number, so it is automatically 1. Carbon, well, there's 3 carbons in this case, and 3 nitrogens. Okay, so you've distributed the 3 back in to what's inside the parentheses. Now, in the case where one of the atoms in the parentheses has a subscript of its own, you're going to multiply. Okay, so this is literally the distributive property, but a little bit backwards, because you're used to bringing the number forward into the parentheses. We're bringing it backwards. So the number of iron atoms is 2, because it's got a subscript 2. The number of sulfur atoms is 3, because we've distributed the 3 backwards into it. And the number of oxygen atoms is 3 times 4, which is 12. Okay. Again, this last little rule is exactly the same as the second one, except that there are subscripts within the parentheses, so you actually have to do the multiplication there. That type of multiplication should be mental at this stage of the game, and you should be able to count these atoms and elements pretty quickly when you see the standard chemical formulas. Okay. The next part is a pretty common rule. Anytime you're writing element symbols, the first letter is always capitalized. One of my classes has chosen the element uranium. Their symbol is a big capital U. Now, in the case that a second letter exists on an element's symbol, as you see it on the periodic table, it is always going to be lowercase. My first period class has chosen the element gold. The first letter is always capitalized. The symbol for gold is AU, so the second one is lowercase. My 8th period class has chosen the element neon for its representation, and so their first element symbol is N, but neon has 2, so the second one is an E. So capital N, lowercase e. So that's the rules for writing element symbols. Okay, the first one's always capital. If there's a second one, it's always lowercase. That's how you can tell the difference between elements in compounds. So now here we've got both directions. You got a little bit of memorizing to do if you are going to be fluent in chemistry. You should know the top 40 elements, both symbol and name. Okay, and I want you to memorize both of those. There will be a quiz on this. I'm basically going to give you the same exact sheet with certain things whited out. I might white out the CR and ask you to write it in. So you'll have the name, but what was the symbol? So you have to do some memorization and some studying there in order to know them all fluently. Okay? Let's see what else we got here to recap. At this point, you should be able to differentiate, which means tell the difference, between the symbols for a single element and that of a chemical compound. Okay? You should also be able to write the symbols for the basic elements using those 2 common guidelines. 1, first letter always gets capitalized. If there's a second, it is lowercase. And now you should be able to count the elements of each type in a chemical compound by looking at the subscripts and counting up what it is that you've got. Okay, so thank you all very much for your time. I hope you have a good night. Adieu.